Hello and welcome back to everyone. This is Sanjeev Century from St. Joseph School. In previous videos, we were discussing about the basics of matrix, and today I am here with a video on types of matrix. So let's start. The first matrix that we are going to discuss is row matrix. So what is a row matrix? A matrix which has only one row is called a row matrix. We have discussed about row in our previous video as well, so you must be knowing that. So its order is 1 by n. Here at the place of number of row, it is 1. So you can see that in the example, you will get cleared from the example. Here in the first example, you can see matrix A has order 1 by 2, means it has only one row and 2 columns. In second example, you can see its order is 1 by 3, it has one row and 3 columns, means matrix which has only one row is a row matrix. The second one is column matrix. A matrix which has only one column is called a column matrix. Its order is m by 1. You will get cleared with the example. So example number 1 is C, whose order is 2 by 1. It has 2 row but 1 column, 2 row and 1 column. And second example is D, whose order is 3 by 1. Here you can see there are 1, 2, 3 row but only 1 column. So it's very simple, row and column matrix. Row matrix only one row, column matrix only one column. The third matrix that we are going to discuss is rectangular matrix. So a matrix in which the number of rows and number of columns are not equal is said to be a rectangular matrix. For example, here in this matrix, its order is 2 by 3. See, the number of row is not equal to number of column. Second example, you can see X, its order is 3 by 2. Its row, number of row is not equal to number of column. This is very simple. The fourth matrix that we are going to discuss is square matrix. Okay, a matrix in which the number of rows and number of columns are equal is said to be a square matrix. Here with example it is very clear. The number of row, the matrix P, whose order is 2 by 2, the number of row is equal to number of column, 1, 2 row, 1, 2 columns. Okay, and the second example Q, you can see there its order is 3 by 3, the number of row is equals to number of column. So it's very simple. So fifth one that we are going to discuss is diagonal matrix. What is a diagonal matrix? It is a square matrix. A square matrix having all non-principal diagonal elements 0 is called a diagonal matrix. Okay, all non-principal diagonal elements. You must be wondering that what is principal diagonal. So first let's get cleared. Principal diagonal or leading diagonal, it is also sometimes known as main diagonal. Principal diagonal, leading diagonal or main diagonal is the diagonal from the top left to the right bottom. Top left is in this matrix, this is the top left to the right bottom. So this is the diagonal, see, this is the diagonal. Okay, so this is the principal diagonal. Understood? So here diagonal matrix is a square matrix. See here, number of row is equals to number of column, 1 2 1 2. Okay, so 2 by 2, this is 3 by 3. Number of row is equals to number of column, and the main diagonal or the principal diagonal or the leading diagonal, its element are non-zero, whereas other element are 0. See, other element are 0, whereas the element of principal diagonal are non-zero. Okay, so it's very simple. It is a square matrix. Sixth one is scalar matrix. Scalar matrix, the diagonal matrix in which the diagonal elements are equal. In a scalar matrix, the diagonal matrix in which the diagonal elements are equal is called a scalar matrix. For example, you can see here, this is the diagonal elements are here, other elements are 0, and the elements of diagonal are equal. Second example, all the elements except the main diagonal, this main diagonal are 0, and the elements of main diagonal are also equal. See, 3 3 3, isn't it? So it is a scalar matrix. Now the seventh one is unit or identity matrix. The diagonal matrix in which the diagonal elements are unity is called a unit matrix. Means in our previous example scalar matrix, the diagonal elements were equal, but here in unit matrix the diagonal elements are 1. See here, this is a square matrix, diagonal matrix, diagonal elements are equal and the other elements are 0, but the diagonal elements are 1. See, the diagonal elements are 1. It is a square matrix. Okay, so it is very simple, and it is denoted by I. Identity matrix is denoted by I, capital I. Here I have said given example for your convenience, two different names A and B, but generally in general form it is represented by I. The eighth matrix that we are going to discuss is 0 or null matrix. A matrix having all elements 0 is called a 0 or null matrix. For example, you can see here matrix P, Q, R, all the elements are 0 and it is represented by O. Okay, capital alphabet, that is O. Now the ninth matrix that we are going to discuss is triangular matrix. Triangular matrix is a square matrix in which all the elements above or below the principal diagonal are 0. Example, you can see here, this is a square matrix. See, row and column, number of row and number of column are equal. This here, elements above principal diagonal are 0 and the elements below principal diagonal are 0. It forms a shape of triangle. See here, here, it forms a shape of a triangle. So that's why it is called a triangular matrix. A square matrix in which all the elements above or below the principal diagonal are 0. Above or below the principal diagonal are 0 is called a triangular matrix. You can see with the help of example, it is very clear, isn't it? So see, it forms a triangle here, it forms a triangle here. In the same category, triangular matrix, another matrix is upper triangular matrix. A triangular matrix having the elements below the principal diagonal 0 is known as an upper triangular matrix. See here example. In upper triangular matrix, a triangle is formed on the upper side. It is a square matrix, triangular matrix, and elements below the principal diagonal are 0. It forms triangle on the top upper part of the matrix. That's why it is known as upper triangular matrix. Here in second example also you can see the elements below the principal diagonal are 0, see, and it forms a triangle above the principal diagonal. The 11th one is lower triangular matrix, a triangular matrix in which all the elements above the principal diagonal are 0 is known as lower triangular matrix. For example, A, B, C 0, and another one is 1, 2, 3, 0, 0, 4, 0, 5, 6. See here, the example of low triangle matrix are here. Okay, so now the 12th one is symmetric matrix, a square matrix A, so that A subscript ij elements, general form, is called a symmetric matrix if A subscript ij is equals to A subscript ji for all I and j. यसमा चाहिँ के भन्न खोजिएको छ भने aij र aji चाहिँ इक्वल हुन्छ. कसरी? अब यो भनेको हामीले यो भन्दा अगाडिको भिडियोमा डिस्कस गरेका थियौं कि ij र ji भनेको के हो भनेर. ओके, I भनेको नम्बर अफ रो र j भनेको नम्बर अफ कलम हो. सो हियर इन एक्जाम्पल सी 1 2 3 2 4 5 3 5 6 a12 भनेको 2 हो. त्यस्तै 2 अगाडि आएर 1 पछाडि जाँदा भनेको a21 भनेको यो एलिमेन्ट हो कि हैन, a12 भनेको यो एलिमेन्ट हो, a21 भनेको यो एलिमेन्ट हो. सी यु क्यान सी दैट दिस टु एलिमेन्ट्स आर इक्वल. त्यस्तै a13 a31 a13 3 यो a13, त्यस्तै a31 are 3, isn't it? And the last one here a23 and a32, they are equal. So this type of matrix where aij is equals to aji, this type of matrix is known as symmetric matrix. Now the 13th matrix that we are going to discuss is skew symmetric matrix. So what is skew symmetric matrix? A matrix B is equals to B subscript ij is called a skew symmetric matrix if bij is equals to minus bji for all I and j. The condition is negative of symmetric matrix, where in symmetric matrix there was bij is equals to bji, but here in skew symmetric matrix it is bij is equals to minus bji. You will get clarified with the example. See here example, this is the example here. See, b12 subscript b subscript 12 is minus of b subscript 21. See here 6 b12, it is 6, but b21 is minus 6, isn't it? So see, negative of this one. So b12 is equals to minus, means minus is equals to, you can see, minus 6 is equals to 6, which is b12, and b13 is 31 is b31 is minus 3, so is equals to 3, isn't it? b13 is 3, and third one here you can see here b23 is 8, isn't it? So here it is the condition over here in skew symmetric matrix is just negative to that of symmetric matrix. Okay, now the last type of matrix that we are going to discuss is equal matrix, and it is very important because a lot of times questions are asked by giving the condition of equal matrix. Two matrices are said to be equal matrix if they have same order and their corresponding elements are equal. These are the two conditions, means they have same order and their corresponding elements are equal. To be equal matrix, these two conditions is very essential. For example, see matrix X, it has order 2 by 2 and the elements are 1, 2, 3, 4. You can see the corresponding elements here. Y 2 by 2, order are same, isn't it? And the corresponding element A11 element is 1, A12 element is 2, A21 element is 3, A22 element is 4. So 3 2 if interchanges here, then it will not be equal to this matrix. So it's very simple. So this matrix are equal matrix as they have same order, that is 2 by 2, and their corresponding elements are also equal. So how the questions are asked, one of the example is given here. Here, if this matrix is equal to this matrix, find the value of x and y. So given, it is given that there are two equal matrix. So now if they are equal matrix, then equating the corresponding elements of equal matrix, we get y is equals to 1, x is equals to 5, isn't it? Y is equals to 1, x is equals to 5. Thus x is equals to 5 and y is equals to 1 are the required answer. I am trying to make you understand by another example as well. Given x plus y, x minus y, 4, 8, 4, 2, x plus 1. So these two are equal matrix, it is given. So now equating the corresponding elements of equal matrix, we get see x plus 1 y, x plus y is equals to 4, equation 1, x minus y is equals to 2, x plus 1 is equals to 4, equation 3, and z plus y is equals to 8, equation 4. These are the 4 equations that we have obtained by equating the corresponding elements. So now when you derive these equations, find out where is the single one. See here, x plus 1, it is a single, it is the equation having only one variable. If it were not here, then you would have used that these two, from where you can derive the value of x and y by elimination and substitution method that you have studied in mathematics. But here it is given easily, so it's very simple. So from third equation we can find out the value of x, and then we can plot the value of x in any one equation here and find out the value of y. And then after finding out the value of y, we can find out the value of z from here by plotting the value of y in this equation. So we will follow the same way. So I will take first the equation number 3. From equation 3, x plus 1 is equals to 4, or x is equals to 4 minus 1, or x is equals to 3. So here I have got the value of x from equation 3. Now I am going to plot the value of x in either equation number 1 or equation number 2. So you can plot in any one. So putting value of x in equation 1, we get equation 1 is x plus y is 4, or 1 plus y is equals to 4, or y is equals to 4 minus 3, therefore y is equals to 1, isn't it? Okay. So now after finding out the value of y, we can plot the value of y in equation number 4, from where we can get the value of z. So now putting a value of y in equation 4, we get okay, here 1, therefore 7, isn't it? Thus x is equals to 3, y is equals to 1, and z is equals to 7 are the required solution. So for today I have some work for you. So work is like this. This is the home assignment that you have to do. Okay, so it is like this, and there are, see, 2 questions, and it has sub questions as well there. First one is state the type of matrix. See here, from the equation you just have to find out which type of matrix is that. In question number 1, there are 8 questions in question number 1, sub questions. Okay, and there you can see and find out, write down the name of the matrix that comes first in your head when you see this matrix. And the question number 2 is from equal matrix, find the value of x, y and z from the following cases. Here there are 4 sub questions, and you have to find out the value of x, y and z that have taught you from the example, 2 examples that I have shown in the previous part here. So these 4 are the questions. Hope you can do these all questions, and I'll continue with the remaining part of this matrix in my next video. Till then, have a good time, take care, stay safe, and bye bye.